Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the concept of capacitors. Specifically, we're going to look at the difference of how we combine multiple capacitors that are either in series or in parallel to give you a single equivalent capacitance. So going from many capacitors to one capacitor. This will allow us knowing the potential to calculate the charge on the plates, among other things. When we're dealing with multiple capacitors, we have to determine in which manner they are arranged. There's one of two possible manners that they can be arranged. Either they're going to be in series or in parallel. When we're dealing with series, that means that we have one capacitor after another, such as this scenario. And what we're trying to do is we're trying to collapse this down into a single capacitor and determine its equivalent capacitance. So 2 to 1. When we're dealing with two capacitors that are in series, the charges on the plates are the same. The magnitude of Q on Q1 is equal to Q2. Furthermore, our voltage is additive. So let's say we just have these two capacitors and an EMF source. Whenever you add the voltage across these plates on both of these, it should add up to what you have for your total. Remember, C equals Q over V. If you need to calculate capacitance, knowing charge and voltage. If there are two capacitors in series, and you want to find their equivalent capacitance, the way you're going to have to solve this is by using this formula right here. Their equivalence capacitance for two or more, however many you have n, you're going to do 1 over the capacitance on each one and find a common denominator. Then you're going to have to take the reciprocal of both sides to get what CEQ is. Alright? So series, the key is that the charges are the same and the voltage difference will not be the same unless the capacitance, of course, on each capacitor equals. So C1 equals C2, then the voltage would be the same. Still additive, but the same. Otherwise, if they're not, then it would be different. So let's look at what's going on in the parallel scenario. When we're dealing with two capacitors that are parallel, what we have is a choice. Our current can either go this way through this path, or it can go this way through that path. Again, notice that there is no physical contact in between the capacitor plates. The plates are going to have an electric field and what's called a displacement current that we will discuss much later. All the energy, again, is stored in the electric field. Just a quick recap of capacitors. So here, when we're dealing with the parallel path, this way or this way, we have that fact that the voltages across both of these capacitors are going to be exactly the same. Whereas the charge on each path is not going to be the same unless C1, of course, equals C2. Then we would have equal charge on each plate. Otherwise, the charge is additive. So whatever the total charge was coming in, it would be split between these two capacitors. Again, there's a formula for finding equivalent capacitance from multiple capacitors in parallel, and you can see that it's additive when you do so. What you're going to do is you're going to take C1 plus C2 plus C3, or however many more you have in parallel. And you can see a good way of getting a high capacitance is by putting them in parallel, because it'll be additive to get their equivalent capacitance. When you collapse it down into a single capacitor in the circuit by doing this formula, you'll see that the capacitance will be much larger. Alright, so that's basically it. You can always use, again, C equals Q over V to determine any values that you need to calculate, and you can always go back from the single equivalent capacitor back to the two parallels or two series by going backwards with the calculations. All right, and all that will be shown in the example videos, so make sure you check those out. And most importantly, practice, practice, practice. That is the key to understanding physics or any other class that you might be taking. All right? Thanks for watching. Have a nice day.